Thank you very much, my friends. How are you doing? What a conference, eh? This Pragma, they organized the most fantastic events. I'm really excited to be here. I must admit, I got a few comments about my title. Yeah, because people told me, you're the person who's going to tell me how my company's going to die. Thank you very much. But the fact of the matter is that there is something happening in the industry that is causing a lot of disruption among companies. So here is my first little quiz to get you going. Of all the companies that were on the Fortune 500, you know, the 500 largest companies in the world, how many of those companies were still on the list in 2014? It's not that bad, guys. Normally I get the answer 2. No, it isn't 2. But actually, more than half of the companies that were on the Fortune 500 in 2000 were gone in 2014. And that's a pretty exciting thing. How can this be? Well, this guy, does any one of you recognize him? You use a product that he invented basically every day. Any guesses? No? Gee, you don't get out much, do you? I mean, this is Douglas Engelbart, the inventor of the computer mouse. Yeah, you remember that? The digital revolution is far more significant than the invention of writing or even printing. So the two things that fundamentally shaped the history of mankind, writing and printing, this gentleman believes that digitalization is a bigger thing than that. That's what we are in the midst of. That's what we, as software professionals, are in the vanguard of. We are the sharp point of the spear that is making this a reality for our societies. Yeah, but the interesting thing is that even though humans are doing really well, and as software people we've never been more popular, companies are having a really rough time. So Jim Collins, publisher of a book called Built to Last, he looks at how long do companies last on the Fortune 500. And in the 50s it was 95 years. Early 90s it was down to 15 years. The latest research shows that companies are down to 10 years on the Fortune 500 and then they get disrupted. So it's actually getting shorter and shorter. So what is happening? Companies fail to innovate and build new core capabilities. You know, they fail to adopt continuous deployment, right? Yeah? So, and digitalization is the new disruptor. Now, very, very quickly, what is digitalization? It's the use of digital technologies to change a business model and provide new revenue and value-producing opportunities. It is the process of moving to a digital business. Now, if you go then, what does this mean? How does this affect the company that I work for? Interestingly enough, if you work in the embedded system space, where I spend quite a bit of my time, we talk about digitally enhanced products, meaning adding software to products that have mechanics and electronics as well. But it's not just that. It's also pure software products, it's digital services, and it's data-driven services. And this is not just something that affects R&D, so the part that you're part of, but also sales, channels, marketing, manufacturing, HR and finance. And this is not just about going agile, this is also about platforms, this is about analytics and data, and it's about your digital partner ecosystem. This is the challenge, my friends. We're in the midst of a digital transformation, and yes, we need software people, and yes, we need DevOps, and yes, we need continuous integration and everything else, but it is actually what is going on is affecting everything in the company, not just R&D or software R&D. So I have 3 key takeaways, because I'm acutely aware that I'm the only thing between you and beer, I think, right? So the first takeaway, digitalization is disrupting industry and society to an extent that we've only seen the early beginnings of. I mean, for the more gray-haired people in this room, I mean, you remember maybe that there were computers that you had to feed paper into in order to get them started and stuff like that. I mean, if you look back at that, you think, wow, we've come a long way. We've just at the very, very, very beginning of what is happening around software and data. Second, companies need a new digital business operating system. The traditional operating system is we work in hierarchical organizations, we use waterfall-style processes, and we make opinion-based decisions that are driven by the biggest hippo in the company. You know what HIPPO stands for? Highest paid person's opinion. And what we need to move to is flat organizations that deliver continuously and that make decisions based on data. And that's what we're seeing. So what we need is speed. We need continuous deployment. Because continuous deployment gives us the data from our customers and from our products in the field that allow us to move to data-driven decision making. Once I have that data, I can make it for improved R&D effectiveness. I can use it for AI, yeah, which I think many of you are starting to look into, or at least playing with, and if you don't, then shame on you, because you should be. And finally, it allows us to move to empowerment. And then finally, we don't want to be an island in a very big ocean full of sharks. We actually operate in a business and software ecosystem, and we have to become much better at making use of the ecosystem around us. So those are the 3 key takeaways that I wanted to give you. And then very briefly, what are we going to talk about? First, I'm going to tell you for a minute or two who I am and where I come from. Then I talk about trends in industry. Then I talk about his new digital business operating system, and by the time you see conclusions, you're going to be really happy, I promise you. Yeah, so very briefly about me. I used to be a young and innocent professor of software engineering. Early 2000, I get a call from Nokia. I started to run one of their research labs in Finland. After 3 winters in Finland, my wife asked me if we could perhaps move to a slightly warmer place. So I get a job at Intuit. Intuit is a company in Silicon Valley, 8,000 people, $4.5 billion in revenue. So I spent several years working as a VP there, and now since a couple of years I'm back in Scandinavia, yeah, in Gothenburg, and I run something called the Software Center. I run a small consultancy, and I'm an angel investor. So if you're planning to start your company, come and talk to me after this. You think I'm kidding, but I'm not. I actually have money sitting in several of those companies. And now, instead of a young, innocent, blue-eyed, naive professor of software engineering, I'm an old, grumpy, and cynical professor of software engineering, as you can tell, right? So I run something called Software Center. Software Center is a collaboration between 12 companies and 5 universities. Tetra Pak is there, Saab is there, Siemens, Bosch, Qualcomm, SEFT is China, Europe Vehicle Technologies, Qualcomm and SME in Gothenburg, Axis Communications, Peter is there with Volvo, Trucks, Volvo Cars is there, Boeing is there through one of their daughters, Jeppesen, Ericsson and Grundfos. Grundfos, Gert, where are you? Gert is sitting over there. Yeah, so all these companies are, I think, customers of Pragma. Is that correct, Life? No, maybe not. I don't know. Yeah, but the goal of Software Center is to improve the digitalization capability of the European software-intensive systems industry. How do we do that? Well, we look into things like continuous integration and continuous deployment. We look into architecture, technical debt management. We look into metrics. We look into customer data, ecosystems, autonomous systems. You know, if there is a buzzword out there, we're doing it. That's how you should think about it. Yeah, we don't only work with metal-bending companies. We also talk on a regular basis with companies like Booking. We have some connections, good connections at Spotify, Rovio, Klarna, King, the company behind Candy Crush, for those of you who forgot. Yeah, no one here plays Candy Crush, right? No one. It's interesting. 300 million plus players. In every conference I give a talk, no one will admit to playing Candy Crush. Everyone will know someone who plays Candy Crush, but no, not me, yeah? So it's kind of interesting. And then the Microsoft Data Analytics team, we have several PhD students that have spent some time there. So that's my background. Trends in industry. First thing, you know, I'm doing more of the management-y kind of thing while trying to keep it entertaining for engineers. How am I doing so far? Yeah, am I doing okay? Good. This is the Gartner Hype Cycle. I'm sure you've all seen it, the technology hype cycle. I don't want you to read all of this, but almost every topic on this list is driven by software. Yeah, here's another slide where you can actually see this. What is the first thing that I do when I get out of bed in the morning? I brush my teeth. How do I brush my teeth? I use an Oral-B electric toothbrush. 2 years ago, Oral-B announced a software ecosystem for toothbrushes. I'm not kidding. They put Bluetooth in their toothbrush, it talks to your mobile phone, and the app on your mobile phone will give you feedback on the quality of your toothbrushing experience. Pretty cool, right? So, after that, everything we do, from logistics to infrastructure to agriculture to sports to electricity generation, telecommunications, cars, even garbage collection these days is driven by software. There's a company that I visited, I think a year ago or so, Enevo in Finland. Yeah, they put ultrasound sensors in these big recyclable waste bins with a 2G connection back to the mothership. Every hour, the ultrasound sensor takes a picture on how full is the waste bin, which allows the garbage collection company to go and collect only those waste bins that are actually at risk of overflowing. 50% reduction in garbage collection costs. I mean, even those people are run by software these days. It's amazing. Self-driving cars, software. Yeah, robots, cute one, I think. Software. Drones in the military space, software. Even the most backward industry in the history of mankind, construction. Yeah, and I'm not kidding. Construction, according to a recent Economist article, has seen 0% productivity improvement since 1947. Do you know how hard it is to have no productivity improvement for more than 70 years? That's almost impossible, but these people refuse to have anything to do with any modern technology. They just don't want it. Yeah? But even these people are now dragged into the 21st century, kicking and screaming with 3D cement printing, automated bricklaying, and God knows what else. Why is everything moving to software? I think that that's an important thing, because that, I think, explains a lot about why do we care so much about continuous integration and continuous deployment and related topics. And this goes back to what I'm sure you've all read, The Lean Startup by Eric Ries. He talks about the build, measure, learn cycle. So I have an idea, I build something, I get a product, I put the product in market so I can measure. These measurements give me data. Out of this data I can learn, and that gives me new ideas. And the idea is, the faster I can go through this cycle, the more innovative I am. Make sense? So let's take automotive as an example. A car platform. Let's not even start with truck platforms for that matter, Peter. Yeah, but a car platform typically lasts 10 to 15 years, which means I go through my build, measure, learn loop once every decade or decade and a half. Now, I don't know where you come from, but where I come from, that's pretty slow. Yeah, so maybe in your entire career you can take 2 or 3 platform realizations that you can be part of. What about a car? Well, a car, it takes typically 3 to 4 years to build. So I go through my build, measure, learn loop once every 3 years. But what about car software? Well, car software I can deploy every day or every week, which means that I can go through my build, measure, learn loop 100, 200, maybe even 500 times faster than any other technology that is in existence. Why do we care about continuous deployment? Because we want those fast feedback loops. I think it's really important to realize that continuous deployment is not a goal in itself, it's a mechanism for us to get to fast feedback loops. Yeah, so keep that in mind. And we can see why everything is moving to software. If you look at this slide by Abed and a few other people, yeah, they show that the size of software in typical systems goes up with an order of magnitude every 5 to 10 years. And the problem is, you know, I've now been a professor of software engineering for more than 20 years. Some of my colleagues from different fields sometimes ask me, Jan, 20 years, have you still not solved this software problem? How hard can it be? Clearly, you're not very smart, is the implied idea, right? But what I then do is I pull out this slide and I explain to them that if I'm building a 1,000,000 lines of code system, the architectures, ways of working, and tooling that work for that, they don't work when I'm building a 10,000,000 lines of code system. And what the architectures, tools, ways of working that work for 10,000,000 lines of code, they don't work when I'm building a 100,000,000 lines of code system. And you know, you think, who builds 100,000,000 lines of code systems? Well, Volvo does. A modern car has more than 100,000,000 lines of code in a car. Ford came out recently with the new pickup truck F-150, and they claimed, I was told, that depending on the model you pick, there will be between 100 and 150 million lines of code in that car. Now, I don't know where you come from, but for me that's a lot of code. Yeah? Not funny? Clearly not. Huh? Data is kind of a big thing. I don't think I have to go and spend much time on this, but there's one reference that I found. You know, I'm trying to be scientific, just to be clear. Is that someone claimed, there was a reference that said that 50 terabytes of data is created every second. I think that's a gross underestimation. I heard from a company in Gothenburg that for self-driving cars, a self-driving car generates around 16 gigabytes per second. Yeah, because you have all the stereo cameras in the front, you have cameras in the back, you have cameras on the side, you have multiple radars in the car, you have ultrasound sensors, you have LiDAR. The amount of data that gets generated is totally amazing. Yeah? The other way of looking at data is in the last minute, according to this study, 204 million emails were sent. If you're wondering, if you have kids, why your kids never stop watching YouTube videos, it's because in the last minute, 72 hours of YouTube video were uploaded to YouTube. Yeah, for those of you in the dating scene, you all look like you're in the dating scene. Yeah, I've heard of this thing called Tinder. In the last minute, 500,000 swipes left to right took basically place on Tinder. And this, my friends, is just data generated by humans. Yeah, for those of you that were in the room before the break, we had to talk from Ericsson. Ericsson predicts 50 billion connected devices by 2022 or 2025 or something. Those devices are going to generate vastly more data than anything that humans can actually generate. So data is a big thing. And that's leading to the next thing, which is AI. I'm not going to spend too much time on this, but I assume you all know the whole notion of deep learning, where you have multi-layered neural networks, you train them, you deploy them, and then they actually go and do classification, prediction, and other kinds of things. Why is this happening? Well, first of all, we're not talking about AI as in chess and checkers. We're not talking about spam filters, that's machine learning. What we're now really talking about is deep learning, multi-layer convolutional neural networks. Why is it happening now? We have much more data. We have much more computing power, we have significant algorithmic improvements, and there is much better tooling. Now, I'm not going to spend too much time on this, but if this gentleman, Sergey Brin, president of Alphabet, tells you that the new spring in AI is the most significant development in computing in my lifetime, that's saying something, I would say. So if you haven't played around with these kind of technologies, go and do play around with it, because I think you need to be well versed in them. Final trend, need for speed. Yeah, speed, not as in the drug. Yeah, just for the record, I'm from the Netherlands, I admit, but that's not what I'm talking about here. What I'm talking about is how long does it take for human beings to adopt new technologies, new products, new solutions that come out in the market. And what we see here is that 4 products, Quicken, a product from Intuit, a company I used to work for, a personal financial management product, eBay, Facebook, and Angry Birds. Look how long it took each of those products to get to 1 and 50 million users. When you put something of value in market, customer adoption is going faster and faster. Yeah, you have less and less time to actually respond. If you don't like customers, but you like money, yeah, here's another example. I have a company, the company sells a product for $1 billion a year, not uncommon for many of your companies, I presume. Most companies express their R&D budget as a percentage of revenue, so in this case we put it at 10%. And if I'm selling at $1 billion a year, then my R&D budget at 10% is $100 million. In Sweden, because of our poor math education, I sometimes have to explain the math. But being in Denmark, I think I'm okay, right? How's that? Is that a nice joke about the Swedes? I know there are many Swedes in the room, so just for the record. No, I'm Dutch, you know. Here's my new product development cycle, it's 12 months. So from the moment I start investing until I can ship, it's 12 months. Now I'm going to give you 2 alternatives. Alternative number 1. I'm going to focus everything I can on becoming more efficient, and I'm successful. I'm 10% more efficient. I can still ship after a year, but I've only spent $90 million instead of $100 million. That's pretty cool, right? Even in a high-tax country like Denmark, that's a nice chunk of change left after taxes. Is that a fair statement? I'm not complaining about taxes, I'm just observing. Let's put it like that, huh? But here's your second alternative. Your second alternative is that I'm going to focus everything on becoming faster. And I'm 10% faster. And what that means is that instead of after being done after 12 months, I'm done after 10.8 months. And assuming I don't cannibalize any existing business, and I can sell at a flat rate of $1 billion a year, I'm adding $100 million of additional top-line revenue just by being faster. Now, what would you rather have, $10 million in savings or $100 million of additional revenue? There is something to this math thing, I can tell. Maybe it's Scandinavian, I don't know. Obviously, yeah, so if I do these talks in the Netherlands, there's always someone who says, I want both. But that was not what I was offering. Yeah. But look at this. You have earned back your entire R&D budget just by being faster. Yeah, so and what happens in companies that focus on efficiency? Well, most companies that focus on efficiency, especially large companies, they put all kinds of things in place. Milestone reviews, board approvals, all kinds of other things in order to make sure that nothing inefficient will ever happen in this company. By extension, nothing at all happens in the company. When you focus on efficiency, everything gets slowed down. When you focus on speed, you go and look for every activity on the critical path that you have, and you look for ways, how can I automate this? How can I do this in a different way? How can I take it off the critical path? And just by focusing on speed, you're actually becoming more efficient as a byproduct. So take this message back. It's not about efficiency, it's about speed. Yeah, you with me so far? Or are you against me? Yeah, you know, people with my last name, Bosch, when they moved to the US, you know, many of them changed their name. You know what they changed it into? Bush. And I used to be really bothered by that, but now I'm thinking at least it isn't Trump. You know? So, very simple. Sorry, I couldn't resist throwing that one out there. I'm not a very smart person. When I walked into this room, the average IQ dropped dramatically. But I can only do simple models. So this is a 3-layer product model. It's a very simple model. The model basically says every product, every platform, every portfolio has 3 layers of functionality. Commodities functionality. Yeah, we're going to come back to this, so pay a little bit of attention here. It's commodity functionality, stuff that you need for your product to work, but no one gives a flying hoot about it. Yeah, so think about when you bought your new mobile phone. The fact that you could make calls with your mobile phone did not factor into your buying decision. You would have been really annoyed if you couldn't make calls with your new mobile phone. That's a different thing. But it doesn't help you differentiate your product vis-a-vis anyone else. On top of that sits a layer of differentiating functionality. That is the stuff that makes your customers pick you over your competitors. And then on top of that sits an innovation and experimentation layer. And the way that this works is we try out typically, the success rate of innovation is around 10%. I try out 10 different things. One of them resonates really well with customers. And what I do is I productize it, I put it in my differentiating functionality layer. It sits there for a while, depending on the industry that you're in, for a few weeks, it's differentiating, a few months, a few years, and then it flows into the commodity functionality layer. Are you with me so far? The answers that a company needs to, or the questions that a company needs to answer are the following. How do I expand my innovation funnel? So that's innovation at the top. For that, I need to partner with my ecosystem. Once I find something that is innovative, how do I bring it to market as quickly as possible? Well, for this, I need speed. How do I know that what I'm building provides value for customers? Well, for this, I need data. How do I know that what used to be differentiating is now starting to commoditize? Again, I need to use data. How do I minimize total cost of ownership for commodity functionality? Well, here I want to partner with my ecosystem. And then finally, how do I organize for all of this? And this is where empowerment comes in. Now, I have a lot of material. I'm going to focus on speed, data, and empowerment, and skip most of the rest, I'm afraid, in the interest of time. But speed, every company moves through a very predictable pattern. We've worked with dozens of companies. Oops, someone is walking out, and I guess I hurt his feelings. I guess he's Swedish, but I'm not sure. So you start with traditional development, and the first thing that you do, you've all gone through this, you adopted Agile. Adopting Agile is actually easy because it only affects R&D. Once you have Agile in place, the next step that you do is you move towards continuous integration. Why do you move towards continuous integration? Because as an Agile team, you want to know that what you're building actually works. Once you're done with continuous integration, you can always ship. Yeah, especially in the embedded systems world, first the mechanics people take a lot of work, and then the hardware, electronics people take a lot of work, and they have all overshoot their time budget, and then the software people get going, and then the software people always get blamed for the product shipping late, because they were the ones that didn't finish on time. Yeah, because everything else is hidden. When you are at continuous integration, you can always ship. When you ship, then becomes a business decision. We can ship now, without these features that are on our backlog, or we can wait a few sprints and ship later and then include these features. But it now is a business decision, not a technology decision, like the quality isn't there yet. Next step after that is continuous deployment. Lots of companies talking about that today. And then finally, we move to R&D as an innovation system. When I start to do A/B experimentation out in the field, so some trucks get one version of an active safety feature, some trucks get another version of the same active safety feature, and then I go and compare which truck is more safe out in the field. How does that work for you, Peter? Is that working for you? I don't know. Yeah, so there are 6 feedback cycles that I care about. Development cycle, what is my heartbeat of development? Requirement cycle, how often can I reprioritize requirements? Quality assurance, how often do I assure that I'm at production quality? Governance cycle, teams do 3 things. They build new features, they fix defects, and they refactor the architecture. Governance is, what is the relative resource allocation to those 3 different things? Deployment cycle, how often does it go out to customers? And then a value creation cycle, how often do I validate that I'm actually creating value for customers? Because this is one of my concerns with many R&D organizations. We tend to pride ourselves on shipping as many features as possible. More features, flow, right? but we never think about how much value are we actually delivering to customers. As a very quick side note, and I don't have time, but I'm going to do this anyway. Yeah, if your R&D percentage in your company is 10%, which means that of the total revenue, 10% of the revenue goes to R&D, it means that for every euro that you invest in R&D, you have to generate 10 euros of business value. Otherwise, the equation doesn't go together. Are you with me? Yeah, so as engineers, we have to have an acute understanding of what it is that actually generates value. And we're going to come back to that. What is important here is that with the 5 steps that you saw on the Stairway to Heaven, the speed dimension of the Stairway to Heaven, with every step you go up, 1 or 2 of those feedback cycles go from long to short. And what is the problem? If I have slow, long cycles, decision-making tends to be opinion-based, which means I've been with this company for 27.5 years. I know the product, I know our customers, and I know that this is what they want. Yeah, that's the hippo talking. Yeah, when you have short cycles, you can actually make data-driven decisions. I'm actually not sure what customers will like, but let's try this, and then let's try that, and then let's look at the data and decide what is the better approach. And many organizations have great difficulty getting to these fast, short feedback loops in which they can learn from the market and from what works for customers all the time. In the interest of time, I have 18 and a half minutes left. We do great work on architectural technical debt. If you want to know more, you have to come back to another talk. We do great work on visualizing continuous integration. These are all the testing activities that happen in a company that was on stage here earlier a couple of years ago. We've looked into continuous deployment, things like the continuous deployment loop. We've looked into continuous delivery model. Here's the thing. Every company that has multiple branches of code for all their different products, the moment you start to move from a slow yearly 6-monthly release cycle for all of these individual products and you move to bi-weekly or 3-weekly release of software, there is no way that you can do that for all those individual code lines, code branches. What you need to do is you have to bring everything together in a single code base, have automated product derivation, have continuous integration on the side. I'm not sure if you can see that. It's on the side and it's late in the afternoon. I apologize for that. Yeah, but that's one of the key things that we have to understand. You with me so far? Yeah, so this stuff is important. It's not just enough to get to continuous deployment for an individual product. If you have multiple products, you also have to bring the code bases of those different products together into one configurable single code base. That was the first dimension. The second dimension is about data. Again, in the interest of time, I'm not going to spend too much time on this, but this is what I actually care about. There's an old study by Standish Group that says, from 2002, which says that in a typical IT system, at a typical company, somewhere between half and 2/3 of all the features that get built are never used or used so seldomly that the R&D effort wasn't worth it. Yeah, so I do quite a bit of consulting with, I think now, 20+ companies, and whenever I walk into that company, I tell them 50% of your R&D is waste. You just don't know which half. I can help. Yes. Sorry, that was a bit of a bad joke. We did our own research in Gothenburg, where we basically, this is a Swedish company in the Gothenburg region that shall remain unnamed, where we see exactly the same pattern. Some features are used a lot, some features are used occasionally, many features are never used. Now, let's be clear, there are features that you never want to be used. My car has an airbag feature. I don't want that feature to be used. And there's a whole lot of stuff that we have in different feature types and all this other stuff. But for the features that we expect customers to use on a regular basis, or we expect the product to activate on a regular basis, on average, 50% of the time we get it wrong. Yeah, and this is why, as R&D, we have to shift from how do we crank out as many features that product management throws over the wall, to how do we get to a much more experimental, test-driven way of development where we constantly verify that what we're doing is actually adding value. And one of the models that we've developed there is what we call the Hypex model. Yeah, so at the Hypex model here you see a very simple flow chart. You pick a feature, and before you start any development on that feature, the first thing that you do is you discuss with everyone who's involved in that feature, how will my product behavior or how will my customer behavior change in measurable terms. So how will I measurably know that the feature that I'm building is actually adding value? And then what you do is, the next thing you do is you build a minimal viable feature. For those of you in the startup community, this is now old-fashioned terminology. It's no longer the minimal viable feature, now it's the MLF. You know what it stands for? Minimal lovable feature. Huh? Yeah, so the minimal lovable feature, so you get the first 10-15% of your feature out, together with instrumentation, and you measure if what you were expecting to see is actually being realized or not. And what you typically see is that there is a gap between what you expected to see and what you're actually seeing in practice. Now, if you see that nothing of what you expected to see is happening, then of course you should abandon that feature. Sometimes you've built 30% of the feature, you've achieved everything you wanted to accomplish. Then you just continue on with the next feature. There's no need to build the rest of the 70% of that feature because you've already achieved the outcomes that you were looking for. Yeah, the other one is that maybe, you know, I see some movement but not enough, so I add a little bit more. And finally, I get data back. I understand that there is some interest in the feature, but I've realized it the wrong way. So what I do is I build it in a different way. So what we claim, and this is what I was first considering to use as a title for this talk, that we are moving towards what we call a holistic DevOps framework. And the DevOps framework means that going forward, R&D organizations will have three types of development. The first type is requirements-driven development. You get your requirements, you build them, you put them out there, you're done. The second type of development, however, is a little bit different. That's what we call outcome or data-driven development. Then, as a team, you get a quantitative outcome target, and you basically have full freedom to do an experiment with whatever you want in order to try to accomplish that outcome. Yeah, so some of the people, I do a little bit of work with Booking.com from time to time, teams there will never see a requirement. Basically, they're asked something along the lines of, your part of the website that you're responsible for currently has a conversion rate of 3.2%. Yeah, so 32 out of every 1,000 people do something that you want. Your goal for the coming quarter is to get it from 3.2 to 3.4%. And how you do it, that's your problem. Yeah, if you want to go meditate on the beach, that's one way to do. If you want to go pogo sticking in the center of Copenhagen, then that's fine too. If you want to do a fundamental redesign of the website, that's great. If you wanted to run A/B tests, everything you want to do is fine as long as you move the needle. Yeah, that's what we call outcome-driven development. The third type of development is what we call AI-driven development. That's when I have large labeled data sets that I can use to train deep learning or machine learning models, and then these machine learning models, once they're trained, are deployed as AI components in my system. And future systems will basically have components developed using requirements, using outcome, and using AI-driven approaches. All these components will live in a continuous deployment context, and all these components will basically push data back to you as a company in order to inform you on how well they are performing. Now, I don't have time to go into AI. I do work with this company, Peltaren. If you haven't looked at them, I think that they rock. I happen to be on the board, so that helps. But they were, I think, close to 60 people, going on 100, EQT funded, so there's a lot happening right there. We do all kinds of really cool things, ranging from predicting energy production to house valuation to cancer treatment to wheat rust to paper mill optimization. I don't want to go there. I want to spend time on one thing. Look at this study from Google. It's a paper from Google. The reference is in the bottom of the slides. They basically show why you should care about software engineering for deep learning. The little black box in the middle is the machine learning code. Everything else around it is configuration, data collection, data verification, feature extraction, machine resource management, process management, server infrastructure monitoring. All these things are real hardcore software engineering that people like us spend time on. Yeah, so there is a paper, if you're interested, I'm happy to send it to you, where we basically looked at what are all the engineering challenges for building deep learning systems. And there are very many very exciting and fun challenges. One of the things that is the hardest, both from a hard to solve and hard from a high business impact, is effort estimation. Because you actually don't know how successful you'll be with a machine learning model. So imagine that you go to the person that gives you the money, yeah, the person that divides the resource, and you tell them, hey, I want to do this project. Okay, interesting. How long it's going to take? I don't know. How much it's going to cost? I don't know. What is going to be the success? How much benefit are we going to have from this? I don't know. You can see that that's a little bit of a difficult conversation. Can you see that? Yeah, so that's one of the key challenges that we're trying to solve in deep learning. Not only this, there's a whole bunch of other things there as well. I wanted to spend a minute, I have 10 minutes left, on empowerment. Does anyone recognize this one? Not sure. Yeah, so for some reason this always goes really well. We have again a stairway for this. I'm not going to go about it, except the only thing I want to say is Agile is a first step on this road. Why do I care so much about empowerment? Hierarchical organizations are good at certain things. Things like effective scaling, controlling many people from a central position, very efficient for repeatable tasks, harmonization of process, globalization, and handling low complexity situations. Yeah? But they have a bunch of weaknesses. They tend to be have very slow decision making. Everything has to go up the hierarchy and down the hierarchy. Power is driven by position, not by capability. You have a tendency to be internally focused and forget that there are competitors out there. It very easily gravitates to politics. Not in Denmark, but in other countries, just for the record. Highly resistant to changes. It's almost, especially the European hierarchical model is actually the worst of both worlds. And challenged by high complexity situations. And we can see this because look at the employee engagement numbers. This is Gallup's, who is collecting yearly engagement numbers. These numbers are from the US, 2013, 2014. On average, 30% of people are engaged in their job. They're there because they are passionate about it. It adds meaning to their lives. They want to do this. Around 50% of people are not engaged. They're basically there for the paycheck. Around 18% of employees is actively disengaged. You know what it means? It means they hate their job so much that if they're alone in the office and no one is watching, they will kick the printer and hope that it breaks just to hurt the company a little bit. Yeah? And now I can see all of you think, but yeah, this is the US, of course. Europe is much better, right? Here are the numbers for Sweden. In Sweden, 16% of employees is engaged, 73% of employees is not engaged, and the only good news here is only 11%, so that's more than 1 out of every 10, is actively disengaged. Yeah, that's the situation we have right now. It's awful. And the other thing, interestingly enough, is the younger you are, the less interested, the less willing you are to work in a hierarchical organization. Yeah, now, I have a whole bunch of slides on this. I don't want to go there. It's very expensive, that as well. But Agile is a first step on this road. Yeah? There's a book that you can download from Frederic Laloux called Reinventing Organizations, who basically, I think, describes 27 case study companies ranging from a handful of employees to, I think, 15,000 or 20,000 employees, where people have no bosses. There are no bosses. They have self-management. They have the advice process, they have roles, they have activities, they have coordination mechanisms, but they don't have bosses. Yeah, and basically he gives a description of why he believes that is. Holacracy was the technology or the approach adopted by Zappos, the shoe sales company that was bought by Amazon a few years ago. And then last there is this book called Exponential Organizations, coming from people from Singularity University, that talks about how companies like Airbnb and Uber can grow so incredibly fast with very small numbers of employees. And again, if you look at it, you will see autonomy, experimentation, dashboards, interfaces, and using social means. So the principles that we're moving towards are basically, I think, very much in line with what the previous presentation is. Principles over orders, personal leadership over leader-follower, trust over audits, customer first over organization structure first, team-appointed managers instead of manager-appointed teams, diversity over homogeneity, agility over long-term planning, and emergent strategy over top-down strategy. Yeah? How am I doing so far? I'm trying to talk as fast as I can. Are you keeping up? I have one more dimension to cover with you, and that's ecosystems. And the only thing, because I want to leave a few minutes for questions, is this one. You remember this model? The 3-layer product model? Yeah, I put the references there because Jacob here told me to look scientific, so there are paper references here, right? So I have now asked well over 50 companies, how much of your resources, of your R&D resources go to commodity functionality? How much of your resources go to differentiating, innovative, and experimental functionality? You want to know the answer? According to our research and all the data that I'm getting, somewhere between 80 and 90% of all R&D resources in a typical company go to commodity functionality. Look to your left and to your right in the row that you're sitting. In the entire row, you are the only person working on differentiating functionality. Everyone else is working on commodity. But this is the state of software engineering today. 8 or 9 out of every 10 in a typical company work on commodity stuff, stuff that no customer gives a flying hoot about. We just have to, it just has to work. And then the 1 or 2 out of every 10 that build new stuff, they get it wrong half the time. I cannot help wonder if there is perhaps a slight room for improvement here. Yeah, can you see where I'm coming from? Yeah, no, good. So we developed something called the 3-layer ecosystem strategy model, which I will not bother you with. The only thing that I want to spend a bit of time on is that there are actually many strategies that companies can employ to free up resources out of commodity and make them available for differentiating and innovative functionality. Yeah, so a company like Ericsson, for instance, tends to move commodity platforms to low-wage countries, typically in Asia, where Ericsson engineers at a much lower wage are doing the maintenance of commodity functionality, so the much more expensive Western engineers are used for differentiating functionality. Volvo Cars, BMW, and a few others, they used the open source creation strategy. They together created the Geneva open source infotainment platform, which was a Linux-based platform for open source for infotainment in cars. And they said, let's share the cost of building the commodity layer so that we can differentiate by ourselves on top of it. Yeah, that was the idea. And then at some point, Volvo Cars decided to go for Google, but let's not go there right now. Finally, Axis Communications is a web security camera company in Lund. I'm not sure if there are any Axis employees here, because there are sponsors. Ah, there you are. I was wondering. I didn't recognize the faces. Sorry about that. So whenever video processing functionality in the Access products becomes commodity, they work for them. They work with the Linux community to get it integrated into the main branch of Linux. Advantage for the Linux community, they get access to pretty advanced video processing functionality early. Advantage for Access, after the transfer, the cost of maintenance is 0. They get it for free. Yeah, so that's a pretty good thing. So there are lots of things that you can do to actually free up things in the commodity layer. Anyone know who this is? He's not Danish, in case you wondered. At least I don't think so. This is George Colony, CEO of Forrester Research. In the future, all companies will be software companies. So if you go for conclusions, I know that this was not an how do you do DevOps in this company kind of talk. This was kind of pulling you back and putting what you're doing and what you're spending time on in a broader context, which I think is important, because I believe that the biggest difference between US engineers and European engineers is that in the US, when I worked there, every engineer knew exactly what business we were in, knew exactly what was value adding, what was not value adding. Whereas in Europe, not you, but other engineers still have a bit of an attitude, just give me the requirements so I can put up my big headphones and start building it. Yeah, without having a real deep understanding of what is actually behind all that. And I think that that needs to change. Digitalization is at the beginning. We've a very, very long way to go until we've captured the full value of what digitalization is delivering. Speed is kind of sort of important. Did I manage to convince you of that? Continuous deployment is a good thing? Yes? Yeah, good. If you say yes, it goes faster. I would have been really surprised if it would have been a no, by the way, at this conference, but let's not go there. I actually was at a large German company recently, and I said, you know, we have to get to continuous deployment. It's really important, blah, blah. And then someone in the back of the room raises their hand and asks, why? That led to a long conversation, but let's not go there. Yeah? So data, I'm not sure how many of you are working actively with data, but data is really important, and we can use it to improve our effectiveness of our R&D for AI, but also for autonomy. Yeah, because we've studied autonomy. If you give teams autonomy without clear goals and targets, quantitative output, it tends to result in chaos. There's a paper on that in case you're interested. So you need to give teams empowerment and autonomy and clear, unambiguous targets to aim for, and then teams can fly. And finally, it's not just you, it is also the entire ecosystem. Now, a final thing before I let you go, I have 6 seconds. The book on the left, I signed away the copyrights for towards the publisher, CRC Press. But the other two I self-published, and I sell on Amazon.com for $9.99 a piece. But for you, because I love you guys to pieces, if you drop me an email, I send the links to those books to you for free. Free as in beer. How's that? Huh? Huh? Woo! And with that, thank you very much for your attention. I appreciate it.